Hello everyone, I am Sanchana studying in 4th SEM Data Science, Sri Venkateswara College of Engineering. So today we are going to discuss about function composition and inverse functions. So let us come to the introduction to the function composition. It is a process of combining two functions to create a new function. The notation for the function composition is typically written as f or g of x, which means f of g of x. This operation allows us to apply one function of the result of another, creating a chain of transformation. So as you see in the picture, it is the combination of the functions f of x plus g of x, or f of x minus g of x, or f of x divided by g of x. How to perform functions composition? To compose two functions, you must first evaluate the inner functions. After finding the output of the inner functions, substitute this value into outer function. This sequential application illustrates how outputs from one function reserve as inputs of another. Write down first the main or outer functions. Substitute the value of the input function f of x, apply the distributive property and combine like terms. Properties of function composition. Function composition is not commutative, means f of g of x is not necessarily equal to g of f of x. However, function composition is associative, so f of g of h is equals to f of g of h. Understanding these properties is essential for correctly manipulating and interpreting composed functions. Composition function uses the output of one function as the input of another. Examples of function composition. For example, if f of x is equals to 2 of x and g of x is equals to x plus 3, then f of g of x is equals to f of g of x, which is equals to 2 into x plus 3. The another example is, for f of x is equals to x square and g of x is equals to x minus 1, f of g of x is equals to x minus 1 to the power of 2. This example illustrates how different functions interact with composed. First, identify the output and the inner function, then write down the other function, substitute each x with the inner function. Introduction to inverse function. An inverse function essentially reverses the effect of the original functions. If f of x takes an input x to output y, the inverse function f to the power of x minus 1 y will take y back to x. The existence of inverse function requires that the original function is bijective, meaning it is both one-to-one and onto. Finding inverse function. To find the inverse of a function, start by replacing f of x with y. Next, swap the roles of x and y, and then solve for y to express the inverse function. Finally, replace y with f to the power of minus 1 x to denote the inverse function. First, write the f inverse as y, then replace each x with y and vice versa. Rearrange the equation for y and write y as f minus 1 x. Properties of inverse functions. The composition of a function and its inverse yields the identity function. F into f to the power of minus 1 x is equals to x, and f to the power of minus 1 of x is equals to x. Inverse function reflects across the line y is equals to line x. Visualizing their relationship graphically, understanding these properties helps in verifying if a function as an inverse and in calculating it effectively. In general, f into f minus 1 n is equals to n, and f to the power of minus 1 f of n is equals to n. Application of function composition and inverse. Function composition and inverse functions are widely used in various fields such as mathematics, physics, and engineering. They are essential in solving equations and modeling real-world scenarios, including transformation in geometry. Mastery of these concepts is crucial for understanding studies in calculus and higher mathematics. Thank you.